Hello friends, welcome to my channel. Let's have a look at a newly appeared problem, that is problem 2395. Find subarrays with equal sum. So in this video, we're going to share a solution based on the set, abstract data type, and check idea. So this problem is actually essentially a variant of the Leetcode 1 two-sum problem. First, I'll read through the statement of the problem, and then we do a simple analysis, and then we share the simple and short code. First, let's look at the statement. So given a zero-indexed integer array called nums, so determine whether there exist two subarrays of length 2 with equal sum. So here actually the subarrays of length 2. So this assumption or requirement greatly reduces the difficulty of the problem. So note that the two subarrays must begin at different indices. So we are going to return true if these subarrays exist, otherwise return false. So here it also specifies what's a subarray. So a subarray is a contiguous non-empty sequence of elements within an array. So here are three examples. So in example 3, so for sure the return should be true because all the elements are the same. So, and there are 3 elements, right? So more than 2. So in example 2, so the array is strictly increasing, so the return is false. So in example 1, so we have 4, 2, 4. So we have 4, 2, which adds up together given 6, and 2, 4 also gives 6, so the return is true. So the constraints on this problem, or we can see the additional assumptions, are the following. First, the array has a length bounded below by 2, so this is actually a consistency assumption or consistency lower bound, and bounded above by 1000, so this is actually a small number. So the second assumption is on the range of elements in the nums array. So we're not going to read through. So with that said, we are going to look at the method. So what we're going to do is the following. So we initialize a set and then do linear traversal of the nums array. And then we check the 2 element subarrays and add the sum to the set. Then during the process, we're going to check the new sum. If the new sum appears in the dictionary, it means we find another subarray of length 2, which has the same sum with the previous 13 subarray, so we return true in this case. After the traversal, if nothing has returned, so we're going to return false. So as this is very straightforward, so we will directly write the code here. So first, I'm going to initialize a aux, so this is a set, right? Then we are going to initialize or get retrieve the length information for this array. So notice that this n is greater than or equal to 2. So in other words, so the problem is a valid problem. Then we are going to do the traversal. So we're going to start from index 2, and then so we write n plus 1. So in this case, the largest I will be n, right? So what we are going to consider is this one. So the sum of nums. So we can check the length 2 array or subarray. So if this temp in this set, so we're going to return true. Because of the way we do the traversal, the 2 subarrays or more maybe with sum equal to temp must be distinct. So otherwise, what we are going to do is that so we add this sum to this set and continue. So that's all, right? So we are going to return false if nothing has returned after the for loop. So that's the full code. Let's do a special case check. Yeah, it passes example 1. Now let's do a generic case check. Yeah, it passes all the cases. So that's about it for this problem. So notice that, so here we actually checked the sum. So there's slightly redundancy. So actually, if we want to, actually we can use a reference sum using the first two elements, and then we check another element and add the new element and minus the earliest element. So this way it's corresponding to a queue, mimicking a queue. So that's also good. But because the length of the subarray is 2, as we mentioned, this greatly reduced the complexity of the problem. So we can directly do here. So the temp complexity does not change in order. So I guess that's about it for this specific problem. Thank you very much.